partial derivative, right? So now partial derivatives here. So the first partial derivative, these are happening in functions where we have multiple functions, where we have different values, okay, different variables. So we have x, y, and z, for example, in one function. So a lot of times we have functions, with one variable, with two variables. Now we have a function with three variables. So that's what the kinds of things that we're dealing with over here. So we're going to use derivative. Now, so when we say, the first partial derivative, that means what? That means, let's say that we have, this is the notation with respect to 2x, for example. So we're trying to find the first partial derivative of the function f with respect to 2x. With respect to x, that means what? That means if you look inside the function that you have to target x. So x is your target. So wherever you have x, anywhere where you have x, you have to work on that. Anywhere where you do not have x, that means you're going to consider that as a constant. Okay? Again, anywhere where you're not going to have x, you're going to consider it as a constant. So let's go ahead. So where do we have x here? So we have x squared on this side, correct? So we're going to have to find the derivative of that. So what's the derivative of x squared? It is equal to 2x, that we all know. So it is equal to 2x. Okay? Now, so what's going to happen, to the other? So now what happens here? So we have so we say that we don't have x here, and we do not have x there. So that means what's going to happen? We're going to treat them as constants. Because we're going to treat them as constant, the derivative of constant is 0. Okay, basically, if you guys remember that, from the derivatives lessons. So that means y becomes a constant, the derivative of that is 0. Z to the fourth power becomes a constant, the derivative of that also is going to be a 0. So basically, your final answer here is 2x because the other two will give you 0, 0. Okay? So this one will be your final answer. Now, when it comes to the same function with respect to y. So that's the same function with respect to y. So we're going to look again, and the target here is y. So that means what? X squared then is going to become a constant, and the derivative of a constant is going to be 0. Z to the fourth also is going to become a constant, so we're going to treat it as a constant. Derivative of a constant is also a 0. So what then is going to be y? So y is going to be, what's the derivative of y is 1, because the derivative of a variable like that is the constant in front of the variable. And what's the constant in front of y? Is 1. So we're going to end up with 1 in this case. Okay? So then, for the third one, what is the partial derivative of f with respect to z now? So that means, again, z becomes our target, which is z to the fourth power. Okay? So z now is our target. Now, what do we have to treat as constant? So x squared becomes a constant, the derivative of that is going to be 0. And then y also is going to be a constant, and the derivative of that is going to also be a 0. So that means, and then what's going to be the derivative of z to the fourth power? That will give us what? That will give us 4z to the third power, okay? By using the derivative formula. So, which is x and derivative of that, that's prime, that is equal to nx and minus 1. Okay, so that's 4 down, x is the third power. So this is how we deal with the first partial derivative of, these functions here, these multiple variable functions.